Let's click the calculus. Let's go to continuity and one-sided limits and click on 14. See what we got in store for 14. We got a piecewise function. Um, this looks a lot like the one I just got through doing. Oh, no, it's not. Okay, I see it now. Anyway, we got the limit of h of x as x approaches 4. So let's head over to the whiteboard. And let's see here. We're going to I'm mixing up some paint right now. Okay, we got it. We got it. We got it. We got something. We got h of x. How about some funky green? 6x minus 2, and x is greater than 4. And then we got 22, some constant here, and x is less than 4. Whoa, doggies, what's all that? Okay, we want to find the limit as x approaches 4 of h of x. What does this mean? This means that we want to find the limit as x approaches 4 from the left of h of x. Now that's going to end up being this. We'll have to use this one here because, right, this says x is less than 4, all values less than 4, and then we want to find the limit as x approaches 4 from the right hand side, so we'll be using this top one because this says x is greater than 4, and then we'll compare values. Okay, simple as that. Now I'm going to let's do what I always do, and that is we're going to sketch something up here, and we'll label, what are we doing, 4? So we'll say 4 is right here. How's that? That's what we'll say. Now let's look at this top one here. Of course, if I plug 4 into this, we get 24 minus 2 is 22. Color we want to do. We'll get, let's see, so we'll say that this is 22 right here. And of course, it's an open circle, right? Because we don't include 22. We can't. We can't include 4, therefore, right, this is x is greater than 4. And it's doing something like that right there. Now let's look at this one. 4, you get 22 actually out, right? But it's still an open circle because we can't include 4. So that's just going to be a constant running right through 22 there, right? It's supposed to be a straight line. So what we have here is a graph, and it's got a missing point in it. All right. Now let's look at this. If you're coming in from the left-hand side, we can clearly see that this graph is what? Well, it's staying constant at 22. Okay, staying constant at 22. And if we're coming in from the right-hand side, we'd be looking at this limit. And of course, as we get closer and closer to 4, we just ride the graph down. What's my y value getting closer and closer to? 22 also. I could probably make the better 22 there, but yeah, that's pretty terrible. Let's do 22 and then put an arrow to where it's crossing there. Okay, so as you can see, this is 22, and since both these numbers are the same, we get 22 as our the limit as x approaches 4 of h of x is actually 22. Now here's a question, is this continuous? And it's not continuous at 4, And the reason for that is because f of 4 does not exist because you can't use it in, it's not in this domain and it's not in this domain. So you see, so if we were running our pencil across the paper, we'd have to pick it up to get to the other side over here and then move. That was part of that continuity part, first part of the button. If you clicked on problem 1, that introduction of continuity, this is kind of what I talked about here. So as you can see, this was one of the first properties of continuity, or in that definition, and this must be equal to a number first off, and it's not. It's not equal to anything. It doesn't exist. All right, does not exist any. Okay, so there you go. And I always click the answer to go through back and check to make sure that everything is working out, and it is. All right. So you want to come on over, practice, and I'll see you there.